3I/Atlas and the Sleeping Giant. The Amateur's Revelation. January 5, 2026. Namibia Desert. Amateur astronomer Lena Botha didn't expect to change science. With her ZWO-ASI 533MC Pro camera and Asker 71F telescope, she'd spent 57 minutes stacking 60-second exposures of 3I/Atlas, now fading beyond Mars, but still bright enough for deep imaging. What she captured wasn't just a comet. It was a paradox. The main tail streamed backward, as physics demanded. But ahead of the nucleus, pointing sunward, was a sharp, structured jet. Not a diffuse haze, not an optical illusion. A collimated streak, bright and defined. She posted it online with raw metadata, exposure times, calibration frames, sky conditions. No enhancements, just photons. Within hours, Dr. Avi Loeb saw it. "This isn't noise," he told his Harvard team. "It's geometry." Using rotational gradient filtering, a technique to suppress star streaks while enhancing compact objects, they processed her data. The nucleus didn't smear. It held firm, a fixed point of light amid moving stars. Multiple frames. Same location. Same structure, Loeb said. This is the first clear view of its core. And the anti-tail? Not chaotic. Focused. In an interstellar object. That shouldn't happen. Yet here it was. Real data, real sky, real mystery. The structure in the void. January 8, 2026. JPL Science Operations. Dr. Rajiv Mehta convened an emergency session, not out of fear, but fascination. "Amateurs are seeing what our models missed," he said, projecting Lena's image. "That anti-tail isn't random outgassing. It's directional." His team ran simulations. If 3I/Atlas rotated every 16 hours and had localized vents on its sunlit side, sublimating CO2 ice could produce a jet aligned with solar radiation pressure, not against it. But the jet's collimation suggested confinement, perhaps by magnetic fields frozen into the nucleus, or by structural channels in the ice. "It's not artificial," Mehta insisted, "but it's more complex than we thought." NASA issued a rare request. Global amateurs, keep imaging. Stack exposures. Share raw data. We're building a 3D model from Earth. Because for the first time, humanity wasn't just watching an interstellar visitor. It was mapping its breath. And in that breath, CO2, nickel, ancient organics, lay the story of a star system lost to time. The Sleeping Giant awakens. January 12, 2026. Las Campanas Observatory, Chile. While 3I/Atlas faded, another object stirred in the outer dark. C/2014 UN 271, Bernardinelli Bernstein, 150 kilometers wide, the largest comet ever found, was outgassing beyond Uranus. At $20 where sunlight is 400 times weaker than at Earth, it shouldn't be active. Yet ALMA detected carbon monoxide, carbon dioxide, and ammonia, signs of violent sublimation. "This thing is a time capsule," said Dr. Elise Dubois, cosmic chemist. "It's never been warmed by the sun. Its ices are primordial, volatile, unstable. And its perihelion? $10.95, just outside Saturn's orbit. It would never enter the inner solar system. Yet it was already awake." NASA's models showed terrifying possibilities. A massive outburst could eject 10 billion tons of dust. Non-gravitational acceleration could alter its orbit unpredictably. If it fragmented, the debris cloud could persist for centuries. But the real wonder was its scale. If 3I/Atlas was a messenger, UN 271 was a monument, a relic from the solar system's birth, now stirring in its sleep. And as both objects moved through the void, one interstellar, one native, humanity faced a humbling truth. The universe is stranger than we imagined, and we're only beginning to see it. The jet that defies simple explanation. January 15, 2026. Harvard-Smithsonian Center for Astrophysics. Avi Loeb stood before a wall of amateur images. Dozens of submissions from Namibia, Chile, Australia, all showing the same feature. A sunward jet, sharp and persistent. "We dismissed it as an artifact," he admitted to his team. "But the data won't let us." Using Larsen-Scheiner processing, a technique that enhances low-contrast structures in noisy data, they stacked 127 independent frames. The result was undeniable. The jet rotated with the nucleus, maintaining its alignment relative to the Sun. "This isn't random outgassing," Loeb said. "It's seasonal. As the comet spins, a specific region, rich in CO2 ice, faces the Sun, sublimates violently, and produces a focused plume." But why so collimated? JWST's archived MIRI data held a clue: magnetic anomalies in the coma. Not strong enough for propulsion, but sufficient to channel ionized gas into a narrow stream. It's natural, Loeb concluded, but exquisitely tuned by its history. Formed in a carbon-rich disk, processed by cosmic rays, shaped by rotation. It's a masterpiece of physics, not engineering. NASA agreed. In a joint statement with ESA, they announced, "The anti-tail of 3I/Atlas is a rare but natural phenomenon, revealing how interstellar comets can exhibit complex activity due to their unique composition and rotation." The mystery wasn't solved, it was elevated. From "is it artificial?" to "how does nature build such precision?" The primordial heart of UN-271. January 18, 2026. Alma Array, Atacama Desert. Dr. Sofia Ruiz stared at the spectral lines and felt a chill. Ammonia, carbon monoxide, methane, all sublimating at $20 where temperatures hover near minus 230 degrees Celsius. "This isn't normal ice," she told her team. "This is clathrate hydrate, cages of water molecules trapping volatile gases under extreme pressure, formed in the cold outer disk of the early solar system 4.5 billion years ago." C/2014 UN-271 wasn't just big. It was pristine. While most comets were baked, fractured, and altered by repeated solar passes, UN-271 had never come closer than Saturn. Its interior was a frozen archive of the solar nebula's chemistry, and it was waking up. ALMA detected asymmetric outbursts, not steady sublimation, but explosive releases as subsurface pressures built and cracked the crust. "If it fragments," Ruiz warned, "the debris could form a temporary ring around Uranus, or scatter into the Kuiper belt." But the real value was scientific. UN-271 offered a chance to study planetesimal formation in its purest form, how icy bodies grew to 150 kilometers before Jupiter's gravity scattered them. "This isn't just a comet," she said. "It's a fossil planet, a world that almost was." Two messages from the dark. January 22, 2026. Global Observatory Network. As January turned to February, two cosmic stories unfolded in parallel. 3I/Atlas, the interstellar wanderer, now beyond Jupiter, its anti-tail fading, its nucleus silent, a brief visitor from another star system, carrying the chemical scars of 7 billion years in the galactic wild. C/2014 UN-271, the native giant, stirring in the outer dark, its 150 kilometers bulk exhaling primordial gases, a permanent resident of our solar system, holding secrets from its birth. Harvard and NASA launched a new initiative, Dual Archive, a coordinated campaign to study both objects as complementary time capsules. 3I/Atlas. How do comets evolve in other star systems? UN-271. How did comets form in ours? The contrast was poetic. One object spoke of galactic diversity, the other of solar system origins. And humanity, for the first time, could listen to both. Amateur astronomers uploaded new images daily. Professionals refined models hourly. And the public, once fearful of aliens, now marveled at the sheer creativity of nature. Because the universe didn't need machines to be wondrous. It had comets, some as small as cities, drifting between stars, others as vast as small moons, sleeping in the cold. And in their silent journeys, they told the story of everything.